Today in pre-cal we learned about solving exponential equations. And the difference in solving exponential expressions, which is what we've been doing previously in equations, is that now these things are two-sided and there is a final answer where x will equal something. Part A is just the different types that we could be given in a homework problem or otherwise. The first thing I want to point out to you is that you want to get the base alone. That's always going to be your first step. To do that, you're going to use inverses. Inverses are just opposites, and that's a concept you learned in Algebra 1. The second thing I need to remind you of is that it is most often easiest to get e or another base by doing ln. So to get rid of these things by taking the natural log. Okay? Let's look at some examples. Number 1. If I have e to the negative x squared equals e to the negative 3x minus 4. Now I have two bases, they're both e. The base is alone in both cases, so that's good. Since the bases are alone, I can take the ln of them to get rid of them. What I do to one side, I do to the other. So I'm going to take the natural log of both sides. Ln and e cancel each other. So I have negative x squared equals negative 3x minus 4. Now this is a quadratic, which to solve, I will move everything to the same side. So I'm going to add x squared to both sides. Those will cancel, and I will have 0 equals x squared minus 3x minus 4. Now I want to factor that, so I'm going to have x minus 4 times x plus 1, because that's what multiplies to get negative 4 and adds to get negative 3. My two solutions are x equals 4 and x equals negative 1. Okay, let's try another one. Example number 2. 3 times 2 to the x power equals 42. And guys, a big part of the reason we're learning this is if something was squared and I said, how do I undo that? You'd say square root. And until now, you have not had a way to get rid of an exponent as a power. Now you do. So our base here is 2. It's being raised to the x. The base is not alone yet. It's being multiplied by 3. To get rid of the 3, I'm going to divide on both sides. So I have 2 to the x power equals 14, because that's 42 divided by 3. Now I have this alone. To get rid of it, I'm going to take the ln of both sides. And in this case, it doesn't cancel because it's not ln and e, but my properties of logarithms tell me that I can bring the x down in front. So I have x natural log of 2 equals natural log of 14. Now to get x by itself, again, I can bring that down by a property. I can divide both sides by ln of 2 because these two things are just being multiplied. And so x equals, and I put this in my calculator, and the value is 3.807. And so that is my answer. The last type of problem that I want to look at is e to the x plus 5 equals 60. My base is e. It's being added by 5, so the opposite would be to subtract by 5 on both sides. So e to the x equals 55. Now the base is by itself, so I'm going to take the natural log of both sides. Natural log and e canceled. And x equals, I'll put natural log of 55 in my calculator and get 4.007. And that's it. Okay, I want to show you two more examples. One that adds several things into one, just so you can get some practice with that. And then one last little topic. Example 4. If I do 6 times 2 to the t plus 5 plus 4 equals 11. Lots of things going on here. My base is 2. It's being multiplied by 6 and added by 4. We'll deal with this part right at the end. Let's start by subtracting the 4 from both sides. So I have 6 times 2 to the t plus 5 equals 7. Then I can divide both sides by 6. 2 to the t plus 5 equals 7/6. Take the natural log of both sides so that I can bring this part down. This is where it's a little bit tricky. Be sure to bring it down in parentheses. So you can see that the whole thing is being multiplied by natural log of 2. Which tells me to divide by natural log of 2 on both sides. So I have t plus 5 equals this right here, and I'm not going to recopy that because I'm running out of space. But then t plus 5, to get the t by itself, I just subtract 5 from both sides. I can put all of this into my calculator, and that's what t is. So t equals negative 4.778. Again, I'm just using my inverses. The last thing I need to show you, part B, is what to do if you're given one that's a quadratic. And I'm going to show you what makes this one different. So, if I have e to the 2x minus 3e to the x plus 2 equals 0. Okay? The reason it's different is because I've got some e's and I've got some non-e's. And so to do this, the easiest way is going to be to factor. I'm going to start by writing this first part as e to the x squared, because that means the same thing as doing 2 times x, minus 3e to the x plus 2 equals 0. Now I notice that it's in the same form as a quadratic. If e to the x was just x, it'd be x squared minus 3x plus 2. So I'm going to factor this. And I know that what multiplies to get positive 2 and adds to get negative 3 is negative 2 and negative 1. Finally, I can set each piece equal to 0 and solve. By adding and then taking the ln of both sides. So x equals natural log of 2, and natural log of 2 is just 0.693. And over here, I have x equals natural log of 1, which is just 0. So those are my two answers. Your homework is A7, which is page 254, numbers 26 to 56, evens only. And 56 is the only one like part B. All the rest you should be able to do modeling it right after the examples 1 through 4 that we just did. Good luck, and let me know if you have questions.